Hello guys, my name is Vinayak Hasmani and I'm presenting today. So in this part of the demo, I'll walk you through the main components of my fast API web service for pose estimation. I use fast API to create two endpoints, as you can see over here: pose estimation and pose estimation annotation. The pose estimation returns key points and metadata as JSON. The pose estimation annotation returns an annotated image with key points and the bounding boxes, as you can see over here. Let's start with the architecture first. When a post request is made, the input is a JSON object containing a unique ID and a base64 and encoded image string. The image is decoded using OpenCV and resized to a manageable width. Then I use TensorFlow Lite to load the pre-trained movement model. Each thread gets its own interpreter using the thread local storage, and lock is applied to ensure thread safe inference. The image is resized and normalized and passed to the model to extract 17 key points. These key points are then scaled to the original image dimension and used to compute the bounding boxes. The JSON response includes the original ID, number of people detected, bounding boxes, key points, and three-time matrices, pre-processing, inference, post-processing times. For the second endpoint, I annotated the image by drawing green rectangles for boxes and red circle for key point using the OpenCV. The annotated image is re-encoded to base64 and returned in the response. Finally, I log the host name of the pod, handling each request. This helps me verify load balancing across pods during testing. In short, this service efficiently handles concurrent requests, perform inference using a lightweight TF-Lite model, and returns results in a both JSON and image format. All right, let's move to a Docker file now. So here is my Docker file, which you can see on the screen. I started with the lightweight Python 3.11 Slim based image to reduce the size. Then I set the working directory to the app. Then to support the OpenCV and TensorFlow Lite, I install the required system dependencies over here, and to extract to keep the image lean. Next, I installed the necessary Python libraries to support the runtime dependencies like TensorFlow, FastAPI, UVCon, NumPy, and all the other things. Then I copied everything from the main1.py, which is my main apply web service, and copied everything from the data where my model is located over here. And then I expose the port 6000 as used by the fast API server. Finally, I run the app using the UVCon binding it to the 0.0.0.0, so it's accessible from outside the container and limited to one worker to avoid threading issues with the TF-Lite interpreter. This image is simple, optimized, and production ready. Now move to our next question, like Docker and Kubernetes installation. So for the Docker and Kubernetes installation, I use these commands. This is for installing the Docker, which I use from the week 4 lab session. This is for create a Docker adapter. This is for installing kubeadm, kubelet, kubectl. This is for checking version. Then after that, initializing the Kubernetes cluster using kubeadm init. And after that, joining the worker nodes, we're using the kubeadm join and the URL I get from kubeadm init. And then after that, installing the network plugin ViewNet. On that, for networking, I use ViewNet, which provides a robust overlay network and easy to configure. All right, let's move to the next part, like checking the node status. I'll check the node status using this. So I can check the node status over here after the nodes have joined to the worker nodes. So this is the node status. Let's move to the next part, which is the post deployment.yaml. This is my post deployment.yaml file, which I created over here. It creates a deployment name post deployment. Over here, the container uses my Docker Hub image. This Docker Hub image, Cloud Post Vinu, and the service listen on the post 6000. CPU and memory limits are set to 0.5 and 5112 MI. I add the readiness and liveness probe to check service health before routing the traffic. This is my post service.yaml file. It uses the node port type to expose the service. External traffic is allowed by external traffic policy local. The request to port 8080 on the VM will be forwarded on the 6000 inside the container. The assigned node port is 3003, which is exposed through OCI. Then let's just move to the Docker image build. How I build the Docker image. I build the Docker image using the command which I'm going to show over here on the local. So I build a Docker image and push the Docker image to Docker Hub using this command, and use the Linux or AMD 64 platform because the Kubernetes is built on that. On top of that, Kubernetes automatically pull this image using the image policy set to always directly in the deployment specification. Now I'm going to show you my OCI dashboard. This is my OCI dashboard. This is my name, Mane Vinayak, and these are my 3 node workers which are running over here. If I go over here, I can see the details of that. And I use the 4 CPU and 8 GB memory for every nodes over here. This is my VCN, and this is my VCN over here subnet. And these are all my ingress rule which I added over here. This is the like public IP of my control node. I have configured the security list to allow the port 3003 so that the node port service was reachable externally. I also allowed internal communication over port 6443 and 10250 for Kubernetes operation. Um, let's just see let's just see now the details about the pod. Let's just see the pods details using this command. So these are my pods. As you can see, all the pods are running and they are so much healthy. And let's just test the pod using the external server. So I'm going to test them using externally, using this from my local system, using this URL and the locust file. If I hit this locust file, is running in the backend, and now I can open the URL on my web server over here. So it's going to running. I'm going to start one. So it's running over here and there is no error. So it means that the nodes are running, the pods are running from outside this VM. Now I can check the logs. I can check the logs using this. So as you can see, the logs are okay, 200 okay, and they are handling the load balancing over here, right? And let's move to the locust file now. So this is the script for the locust. This is my locust loading script designed to simulate the concurrent user sending image request to the cloud API post. At the start, I preload all the images using in the input folder. Base 64 encodes them and stores them in the memory. Only images under 1 MB are loaded to ensure compatibility with the API. I defined a user class named pose estimator user with 2 tasks. One sends request to the API, pose estimation endpoint, expecting a JSON response with key point. The other hits the pose estimation annotation, which returns a base 64 encoded annotated image. Each task randomly selects a preloaded image and send it to a new UID. I also handled error using catch response to track failures in the locust UI. Here's a quick demo. So here's the quick demo. I run the locust. I run the locust from the master node, and as I can see here, when I let's just see. So I'll just load it. I'll give you 100 user. I'll give a runtime of 5 minutes, and so now the locust is running. The locust is running, and as you can see, there are no errors in the locust. It is running properly. Thank you so much for that.